So today we're going to do some free body diagramming and just a couple of things to remember. You got to use arrows to represent the different forces acting on the object, and we always use a square to represent the object because it could be any object at all. And the other thing is when you use arrows, you have to label them so I know which one is which on your diagram. So the first one, not too bad. A book is at rest on the table. Hey, look, here's our book. It's a square. We need to diagram the forces acting on it. Well, if it's on the earth somewhere, it must have the force of gravity acting on it. And so we represent that as a little f, capital F with a little g. And because it's not falling through the tabletop, it must have a support force acting on it. And that would be in the opposite direction. Now, the other thing that you have to be aware of is because it's really hard to make the arrows exactly the same size, this book is at rest, so it's not moving anywhere, so we know that those forces have to be the same size. But to represent that in your diagram, it's a little bit hard without a ruler and being exact and taking like a forever trying to draw these things. Easy peasy way to do that is to just put a hash mark between the forces that are exactly the same. So then I don't have to worry about the length of your arrow or anything. I know that those two forces are equal. And those are the only two forces on that book. Next one, girl suspended motionless from the ceiling by a rope. Okay, this is not somebody being hung. This is like a trapeze person. You know, where they doing those people in the circus that do the work with the silks, that kind of thing. So again, first thing we always have to put in here is the force due to gravity. And it's being hung motionless from the ceiling. So we have a support force, but it's a particular support force. It's the force of tension because it's hanging. The girl is hanging there. And because she's motionless, that means that those two forces have to be the same. So we'll put a little hash mark in there. The next one, let me slide the paper a wee bit. The next one, we got an egg free falling. Now, if something is free falling, remember, it means that the only force acting on it is the force of gravity. So let's draw our egg. It's one of those newfangled square eggs, not. And we know that because it's on the earth, we must have the force due to gravity. Awesome. And that's the only force acting on that egg. The next problem, slide you down a little bit here, is the egg that's falling, but not freely this time. So let's start out the same way. It still has the force of gravity acting on it. But this time it has air resistance. And you can say force of air resistance, or you could say force of friction, because air resistance is a special type of friction. Now, it doesn't actually say that it is what's going on with its velocity, if it's accelerating or not, so we can't really put any hash marks in this one. We don't really know if the forces are equal or if they're not equal. So that's all we can do for that one. The last one here, let me see if I can move this out here a little bit further. There we go. Is a rightward force. So here's our object. We're back to our book. We got a rightward force. This time we're going to call it force applied because it's applied to a book to move it across the desk with a rightward acceleration. Consider frictional forces. Well, I kind of jumped the gun here. We also have, because it's on Earth, we have the force due to gravity. Yeah. And because the book is not falling through the table, we must also have a support force. And we know since there's no movement or no acceleration in either of those directions, those two things have to be equal. Okay, now back to our original thing here. We have a rightward force applied. We got some air, we got some friction. So it says that it's accelerating to the right, so the force of friction has to be to the left. And we know that the force of friction has to be less than the force of the applied force because it's accelerating to the right. Okay? So that has quite a few forces on it. But still, if you take them one at a time, I kind of messed you up a little bit by starting with the force applied. Whenever you're drawing these things, just start with the force of gravity. It's going to have a force of gravity, and then think, is it falling through something? No. If it's not, then it has a support force, and those two things are equal. Okay, I'm going to slide that paper out and do the last couple of problems. Let's see if I can find the right paper here. There we go. Okay. So now we had a rightward force applied to a book in order to move it across the desk at a constant velocity. If it has a constant velocity, then the acceleration equals 0. Okay? If the acceleration is 0, that means the forces are balanced. So keep that in the back of your mind. So here's our book, and we know, because it's on the earth, we have the force due to gravity. Okay? And we also have a support force. Awesome. So it's applied to a book in order to move it across the desk with a constant velocity. So we can go force applied this way. You could do force applied the other way too, if you want. And we also have force of friction. Now, because it has an acceleration of 0, that means that the force applied and the force of friction have to be the same. And because it's not falling through the desk, that means that the force of gravity and the support force has to be the same. Notice I used 2 hash marks for these 2 forces and only 1 for those, because if you use 1 hash mark all the way around, it means that all the forces are equal. But we don't know that the support force and the force of gravity, we know those 2 are equal, but we don't know if those 2 are equal to the other 2. So we do know that the applied force and the force of friction have to be equal to each other in opposite directions because the acceleration is 0. Okay. Last couple here. Next one is kind of a variation on the book sitting on the desk. So here's our car, stopped at a stoplight. So it's on Earth or some planet, I assume Earth. So we know we have the force of gravity. Now, it stopped there. It didn't say it's falling through the pavement, so we must also have a support force. And because it's not moving, that means that there's no acceleration, so those 2 forces have to be equal and opposite. Okay, last one. Skydiver is descending with constant velocity. There's that constant velocity again. So that means the acceleration equals 0. Consider air resistance. Diagram the forces acting on the skydiver. Well, here's our skydiver, looking remarkably like the car that was stopped at a stoplight. We know it's happening on the Earth, so we got a force due to gravity. We also have force of air resistance, or you could call it the force of friction, either one. And what do we know about those 2 if we have a constant velocity? Well, constant velocity means that there's no acceleration so there can't be a net force. So these 2 things have to be equal. It's still moving, but it's just not accelerating. Okay, so that takes care of those 8 problems. Thanks for joining me. Have a great day.